Right, says live, so I should be live. Welcome in, everyone. Happy Friday. Hope everyone's doing well. I am going to be having a live stream just in case anybody needs any help with their math. And yeah, hanging out on my board and just, trying to sharpen my skills. So I hope everyone is having a fantastic Friday. And yeah, I am kind of running behind today. However, I'll celebrate wins because I actually spent 15 minutes of my spare time figuring out my mistake. And it is in the matrix of minors, just like I suspected. And yeah, for some reason, I'm having, I work with the same problem on my paper, and it only takes me like 10 minutes. And then for some reason, when I get up here and I try to work on my board, it takes me like 30 minutes, 45 minutes. So I don't understand why it takes me so much longer on the board, but I'll figure it out maybe, hopefully one of these days. Anyway, what I'm going to do is I'm just going to correct my mistake and solve the rest of the problem. So I'm really going to try hard not to erase all of this because this is correct and the mistake lies in here. In the matrix of minors, it's a visual thing. So I feel like when I'm working on my paper, I have the original matrix and then the matrix of minors below it. And so I'm able to kind of see it visually. I think it has something to do with maybe the horizontal layout of the board possibly. Anyway, it is what it is. And yeah, all right. So I have the correct matrix of minors here. And my goodness, that looks, I guess I don't know how to focus this camera on my own. So I'm going to try again. It looks blurry to me. All right, that might be a little bit better. Okay, so we have 3, 9, -7, -17, 2, 9, -4, -17. This one is 2, 3, -4, -7. And then this one, I have -6. Okay, so this one right here must be incorrect. What did I do? So let's see, if I'll cross out these 2 rows. And somehow I wrote the wrong matrix of minors in this one. Tragic. Spend a lifetime trying to find my mistakes because I'm that imperfect. Like, I feel like I make more mistakes than the normal person, and it's just part of my personality, so I'm kind of getting used to it. Anyway, so we've got to fix this one. We'll start there. It's very easy to do, as you can see, very easy. All right, so I'm going to write the correct name here. It looks like I switched them, maybe. I wrote the one that goes here, so I might have just swapped these out. Anyway, like I said, it's tragic when you're on live television and you make a tragic mistake like that. It is, but it's not the point to be perfect, so I just have to remember that. All right, so we've got this one right here. So this is -6, -15. And it will lead to an incorrect answer, but -6, -7, and -17. And then this one is -6, -15, 3, and 9. Just double checking it. Yeah. All right. And so we'll check these other ones real quick, but I'm pretty sure that those are the only 2 that I messed up. And I don't know what I did. I just get in a hurry. For some reason, I don't breathe properly in front of the camera, so that's also something I have to work on. So it looks like I've got the good ones. The rest of them are good, so I just have to fix these 2. these two got swapped. So in my matrix of minors, this is row 2, column 1, should be -3. And let's see, row 2, right here is -3, and then we have -9 here. All right, perfect. So what we'll do is we'll scrap everything else, we'll rework it from there, and then, yeah, I'll just call it good, because I don't know about you, but I'm exhausted from this week. And yeah, so I'll just get on to my Friday festivities, and hopefully we'll leave the steps up, leave that, erase this, because we're going to transpose a different matrix because of that mistake. So we'll leave the steps up. I kind of like that I did that. I'm trying to learn every day and make adjustments, slight adjustments in my technique so that I'm improving myself and working on a path of improvement just to be a little bit better today than I was yesterday, and realize that do myself a favor and just try to not put myself through undue stress. So I am going to go ahead and recalculate my cofactors slightly, and we'll just write the matrix and go from there. So I typically will lose my head and just erase everything by habit, but that's not necessary this time. So we've got all this worked out. All I have to do is now apply this cofactor rule to my matrix, and I want to just, I feel like an ounce in time saves 9, and I need to learn that lesson. It's like practice what you preach. So a little bit hard on myself, but if I don't do that, then basically I won't grow. So it's important. Growth, personal growth is important. So my original matrix was -12 to -2. How did that work out? Okay, so I gotta really watch my signs. I'm gonna look here. Okay, it says 17 times, okay, so we've got 17 times 3, that's -51. And we're gonna subtract it by, let's see, -7 times 9, which is -63. So if you have, let's see, that's where I went wrong. -51 plus 63. That's +12. Okay, that's good. So it becomes negative. And let's double check real quick. Okay, so it's 1/2. Okay. So it's +2. Okay. All right. So I have my matrices. I have my inverse actually in the calculators. I'm looking at it to make sure that this goes solid. So I just wanted to double check that one. I think the rest of them are good. Just double check real quick again. So we have -3, -9. This one's -9. All right, so we've got row 1, column 1 is 12. Row 2, that's 2. It's saying this is -9. -3, -9, 3, 3. So we've got 12, 2, -2, -3, -9, -3, -9, 3, 3. All right, perfect. So now we will apply the rule of cofactors. This here, and what we're doing is multiplying each one of these elements in this array or a matrix And what we're doing is we are going to multiply it by the factor of either +1 or -1, depending on where the position is in the matrix. So this first position gets multiplied by a positive, and it stays positive. This one becomes a negative. This is already negative times a positive is a negative. Two negatives make a positive. And 9 is already negative. -3 becomes positive. -9 stays negative. 3 is negative. And then 3 is going to stay positive here. All right. Okay, good. So now what I need to do is I need to transpose this matrix. Transpose. And you transpose it by taking the diagonal. Diagonal is going to stay. 12, -9, 3. And we're going to swap out along the diagonal. So the 3 and the -2 switch. -9, -2 switch. And -3 and +3 will switch. So we've got 3, -3. So after you transpose it, then we're going to multiply it per the method by the determinant, the scalar, 1 over the determinant. This is my adjoint, okay? This is my adjoint matrix. Well, it's an adjoint of the matrix, okay? It's the adjoint of the matrix. All right. So next step is to multiply to just get that inverse, okay? So what we're doing, so recall the determinant, we calculate determinant, and it was 6. So we're just going to multiply each element by the scalar 1 over 6. And we'll do that, and we'll put the answer here. I should be able to just do this in my head pretty quickly. So 12 divided by 6 is 2. 3 divided by 6 is +1/2. -9 divided by 6 is going to, let's see, -9 divided by 6. There's a lot of -9s in here, so that's okay. So we've got, this is -1 times 3 times 3 over 2 times 3. So we're going to cross out common factors, and we've got -1 times 3 in the numerator. That becomes -3. 2 is left over in the denominator, so we've got -3/2. And that's how you reduce a fraction. So -3/2. And I'll erase that because it's in my way. And then we've got -2 divided by 6. So that's going to be -1/3. -9 divided by 6 is, again, -3/2. -3 divided by 6 is -1/2. -2 divided by 6 is -1/3. 3 divided by 6 is +1/2. And then we've got a double 1/2. And we'll just double check the calculator. We'll just double check that calculator real quick. Make sure. So I've got 2, 1/2, -3/2, -1/3, -3/2, -1/2, -1/3, 1/2, 1/2. Perfect. Okay, so this is finally day 3. Again, I wish I had more time in my day to dedicate to my math, to be honest. I'm working on that. So hopefully I get a point where I'm able to just do math all day. That would be so cool. That would be I would be living my best life if that were the case. All right. let's see. So this is our inverse of our matrix. Star it. I'm very happy that we found it. And now all you have to do per this method here is multiply by the constants to solve this problem. And again, I just want to remind everyone that, you can see -3, 1, -4. It's not necessarily the best way to solve this system. What we're doing is we're taking a more simple problem and we're applying a more complicated method so that we can practice the complicated method so that we may be able to solve a much more complicated problem using the method. So that's kind of the game to math. You start out simple and you slowly work into something more complicated. So I know that I am very confident in solving 3 variable linear systems algebraically. And you can do it pretty easily. It's not, anything crazy. But when you get into 4, 5, and many, like you can have a system that has 50 variables or 100 variables or 1,000. They use in encryption. Data encryption is the #1 application for matrices and systems of linear equations, I think. That is the biggest implication, is being able to encrypt data. And they're using these matrices that are so large that they have to have quantum, like fast computers to figure them out. So I'm not saying like at that end of it, but when you get a system that maybe say has 10 variables, it's going to be kind of hard to solve that algebraically. So you would want to go ahead and incorporate some techniques in your matrices, linear algebra. So yeah, that's what we're doing. And I'm trying to introduce something to my fellow people of the world, it's my true goal in life to maybe help, maybe just a couple people understand math, and usually they end up understanding it better than I do, and that's perfectly fine with me. And that is I feel like that might be my contribution to society, maybe. If I can do the math, you can do it too. So anyway, enough of the rambling soapbox. Let's go ahead and finish solving the system. And remember, we're just multiplying these matrices. So we're multiplying a 3 by 3 by a 3 by 1. And they are compatible. And so we can multiply them. What you're doing is you're multiplying the rows times the columns. And you're using this concept called the dot product, where you're multiplying and adding. And it's a multiplication and addition combination. So we're going to take this row times this column, and it's going to produce the answer to this position of our new matrix. So when you multiply a 3 by 3 times a 3 by 1, you produce a matrix of 3 by 1 size. So we got 3 rows and 1 column. And order matters. So we're going to take this position, 2 times this position, -3. So we've got 2 times -3 plus 1/2 times 1, and -3/2 times -4 plus -3/2 times 4. So we got 2 times -3 is -6. That's plus 1/2. And that is -3 times 4 is -12 divided by 2. So how do we want to do it? We'll get them all in. How about we'll do common denominators. So wait, That's okay. Two times -3, 1 times 1/2, and -3. Okay, let's just see how it works out. Oh, -3 times -4. Hang on. I am so glad I caught that. Let's see. That is really, really good. I'm gonna celebrate that one. All right. So this becomes a positive. Yeah, it's not negative. So this one's gonna be positive. All right. So I know that 12 halves is positive 6. I have a -6 plus 1/2 plus 6. So those go to 0, and that just equals 1/2. Perfect. And that's what I expected because I already have my solution up there. And half of the people that watch this video are like, why is she doing all this work? She's already got the answer. Well, the point of it is to do the math and understand the math and be practiced in the math and understand every step. So that's the reason why I do it. So we got -1/3 times -3. And as you can see by how sloppy I am, I obviously need the practice. So it's not like I'm wasting my time, I don't think. So we got -3/2 times 1. Plus -1/2 times -4. All right. So this is a negative. 2 negatives make it positive. 3 divided by 3 is just 1. So we're going to simplify that early. -3/2 times 1. So that is going to be plus a minus. So that's going to be minus 3/2. And then 2 negatives make a positive. So that's going to be positive again. And that's 4/2. 4 divided by 2 is just 2. So plus 2. So we've got 1 plus 2 plus 1 equals 3 minus 3/2. We'll get this in improper fraction. 3/2 is the same as 6, or 3 is the same as 6/2. So we'll have 6/2 minus 3/2. 6 minus 3 is positive 3/2. Right. This will be positive 3/2 here. And that is correct. Excellent. And we've got one more. We're going to multiply this row times this column. And we'll do it here. It's -1/3 times -3 plus 1/2 times 1. And we're going to say 1/2 times -4. Perfect. So -3 divided by 3, that is 1 plus 1/2. And then -4 divided by 2 is going to be -2. So slightly different. We've got -2 plus 1 is, so that's going to be -1 plus 1/2. And that's -1/2. So that's 2/2. See, I'll just show it real quick, but it's -2 divided by 2 plus 1/2. And so you have -2 plus 1 is going to be -1/2. Perfect. All right. So that is an extremely short video. Well, actually, I can't believe that didn't seem like 24 or 25 minutes. But we have the solution here. We'll start that. And yeah, we already have it written here, but we've actually found it. And so hopefully, maybe one of these days, I will get a video editor out and just splice all of these videos together and cut out the fluff and make a short tutorial on it. But in the meantime, I don't have those skills yet. So unfortunately, yeah, I'll just go with it. Hopefully I'll get better and better every day. Anyway, I'm going to go ahead and stop there. I don't have any students and I don't have any questions. And so I will just, we'll go ahead and we can end it now. And I'm going to celebrate this as a success. I hope everyone has an amazing rest of their Friday evening. And thank you so much for watching my video. And I will say bye for now. And I will see everyone next time.